Welcome, power learners! Today we're going to do an experiment about surface tension with pennies. So we've talked about surface tension before in the videos Make a Paperclip Float and Make a Soap-Powered Boat. The links to these videos are in the description box. You should watch both of these videos before or after watching this one.
For this experiment, you need some water, milk, and oil. You also need 3 pennies and a dropper. Underneath it, you should keep a paper towel because it might get a little messy. You should also draw a chart like the one I have over here so that we can write down our data for the experiment. So, let's begin. So the first thing you're going to do is take your dropper and fill it with water. Then, you're going to slowly drop it over the penny and count how many drops you put on it. 1, 2, 13, 14. Okay, so now what we saw was that a small bubble formed over our penny, and it's still kind of there, but after 13 drops, the whole bubble, or at least most of it, exploded. So what we're going to do is we're going to clean off the top of our penny, and we're going to do that again. But before we move on, we're going to go to our chart and write down how many drops it took before the bubble exploded, which was 13. So this is trial 1. So now we're going to go on to trial 2. So see, as you can see, we cleaned it off, and we're going to start dropping more water onto it again so that we can repeat the experiment so we get more accurate results. 1, 2, 19, 20, 21. So it took 20 drops until that one exploded. So as you can see, only one trial is not going to always work. In this, one trial is not enough to see how long it actually takes. So now we're going to do it a third time. What we're testing in this experiment is an actual scientific term that we're going to talk about after our experiment is over. So make sure you watch until the end to learn about what we're testing. So we're going to repeat it one more time. 1, 2, 29, 30, 31. So yeah, it exploded. So that would be 31 drops. So you might be wondering why it keeps increasing. Well, one thing is that the rate that we're doing it, like how fast we're dropping it, might change, and this might affect what our results are. So try to keep a constant rate while you're doing this. Now we're going to test this with oil. So we're going to do the same thing with oil. So the reason why we're using a different penny is that so that our penny's not contaminated, so it doesn't have another substance on it, so our results are more accurate. 1, 14. So after 14 droplets, our oil exploded. So now let's try that again. So again, we need to clean up the top of our penny. 1, 2, 14. So it was 14 again. So as you can see this time, there wasn't a great increase like there was with the water. So that's telling us something about oil. So now we're going to clean it off again. It doesn't have to be too accurate. You just have to try so that you just have to make sure that there's not too much on the penny so that your results are more accurate, basically. 1, 2, 13. So this time it was 13. So what does this tell us? This tells us that whatever we're testing, water has more of it than oil does. So now we're going to do the same thing with milk. So now before we move on, we're going to clean out our oil in the water so that our dropper isn't that contaminated when it starts taking the milk. So now we're going to do the same thing on the third penny with our milk. 1, 23. So that one was 23. That's the highest we've seen on a first trial so far. So now let's do the same thing. We'll clean off the penny, we'll take more milk, and we'll do the same thing 2 more times. One, 16, 17. So that one took 17. Usually for the water it increased, for the oil it stayed the same, and now for the milk it has decreased. So now one more trial. One, 2, 18. So that one took 18. So now we're going to start talking about what we're testing and what our results prove. So now we're going to go over what surface tension is quickly. So for a more detailed description about surface tension, watch the video, Make a Soap-Powered Boat. So there's a scientific term, cohesion. Cohesion is when alike molecules stick to each other and are attracted to each other. So when two water molecules stick to each other, this is cohesion. But when a water molecule and a molecule in glass stick together, this is adhesion. So adhesion is when two different molecules stick and are attracted to each other. So cohesion is what allows surface tension to occur. Surface tension basically provides a film over the surface of the water and lets things stay on top of the water if the water molecules are still sticking together. So when things fall in the water, it's because the surface tension breaks and lets it through. So in Make a Paperclip Float, like the picture that you see right over here, this is basically what we did in the video Make a Paperclip Float, and we lowered it into the water slowly so that the surface tension wouldn't be broken. And because it wasn't broken, we were able to make it float. If you see around the paperclip, there's like a slight dent. It's because the water is basically sticking to each other underneath the paperclip and keeping it afloat. So now let's talk about surface tension in relation to our experiment. The dome that occurs over the penny is a result of not just water molecules, but any of the molecules in the liquid sticking together. So the more drops that the penny can, the more drops the dome, the more drops it takes until the dome explodes, the more surface tension the liquid has because it's able to stick together and cling on to each other. If it just explodes quickly, that means the surface tension is not as strong, so it's not sticking to each other as strong as if it had more surface tension. Again, remember, water is not the only liquid with surface tension. So we tested 3 liquids, and all of them showed signs of having surface tension. So it's not just water that has surface tension.
So I've arranged the data that I got from our experiment into a bar graph. So let me take a few seconds to explain what this bar graph is saying. So on the bottom, I have the three materials that we used, the three liquids we used to test their surface tension. So these are milk, oil, and water. So each of the bars represents either trial 1, trial 2, trial 3, or the average of all the trials. The average is when you add all your data and divide it by the number that you had. So for example, oil. To find my average, I added 14 plus 14 plus 13. Then I divided by 3 because I added 3 numbers together. If this is just a general note, if you get 0 as something in your data, you still count that as 1 point in your data. So let's say oil was 14, 14, 13, 0. You add those together and you divide by 4 because 0 counts. So that's just a side note when you're doing things with average. So then, as you can see, water has the highest average, meaning based on our results, water has the most surface tension. Then it's milk, and then it's oil. So this is the actual chart that I've explained, and now we're going to talk about data in general and what our data proves. So our data, like I said, means that water is the most surface tension, then milk, then oil. But now we're going to talk about data in general. So we've collected our data into a bar graph. We've organized it, and this helps us organize it and visualize it and see what our data looks like and what numbers and what are the highest and what are the lowest, and to really see what our data is saying. The importance of organizing your data is that you're able to prove theories and test ideas in a more organized fashion. And what's the importance of collecting data? Again, to prove theories and test ideas. So if you have a hypothesis, if you have a question and you want to prove it, you need to collect data to be able to prove it or to find an answer. But what is the importance of how we collect our data? Why did we take 3 trials instead of just doing 1? Let's look at our first trial. Water took 13 droplets, oil had 14, and milk took 23. From just trial 1, we see that milk has the most surface tension. Now let's go to trial 2. Water took 20 droplets, oil 14, milk 17. From this data, water is the highest. Then water had 31, oil had 13, milk had 18. Again, water is the highest. Then we look at our average. So water is the highest in general, 21.3. Then milk, 19.3. Then oil, 13.67. But if we had just stuck to trial 1, we would have said milk had the most surface tension. If we had just stuck to trial 2, we would have gotten our results, but the numbers, the averages and the number we got, they're all pretty close, but our average really tells us our average is the closest number to to the accurate number of to see which one has the most surface tension. That might have been a bit confusing, that last sentence, so let me rephrase it. Because we took our average, we can see what the overall data is like. We can summarize it into one number, and we can really see which one's the highest and which one's the lowest and which one's in between. So you want to take as many trials as you can to get the most accurate data and to get your most accurate results. So this is This is surface tension with droplets on a penny, and data and the importance of how we collect it and how we organize it.